I'm Steve Yantis, and I'm a professor of psychological and brain sciences at Johns Hopkins University. In conducting this study, we were interested in understanding how people controlled attention to different sensory modalities, how people controlled attention to vision and audition, which is a kind of task that we're confronted with all the time. When I'm reading a book, I may be less aware of someone calling my name somewhere else in the room. Or when I'm focusing on something visually, I may not hear someone coming up from behind me. We set up a situation where people were seeing and hearing continuous streams of information, sort of like what you would be confronted with in everyday life. In this experiment, people were looking at a computer screen to a continuous stream of letters that were changing quite rapidly, one after another, in the center of their visual field, and at the same time they were listening through headphones to a sequence of spoken letters, and at any given moment they were monitoring either the visual stream or the auditory stream. We put them in an MRI scanner, which is a device that allows us to measure brain activity over time, and we measured changes in their brain during the course of the task, and in particular looking at moments in time when they were shifting attention from one modality to the other. When they saw a digit, they pressed a button to indicate that they detected the digit, and then the identity of the digit told them what to do next. So when we looked at the results of the brain scans, we found two kinds of patterns. The first pattern related to whether the person was attending to vision or audition. And we found that when the person was attending to vision, the visual parts of the brain in the occipital lobe were more active than when they were attending to audition. And at the same time, the parts of the brain that are responsible for audition in the temporal lobes were less active than when they were attending to audition. It's as if the participants were changing the volume on the visual input and the auditory input according to where they were supposed to direct attention. It was the first direct demonstration that changes in the attentive state of the observer shifting between vision and audition had immediate consequences for brain activity. The issue of shifting attention between vision and audition has some obvious practical implications. When you're driving in your car and talking on a cell phone, you are faced with a multitasking situation. You're sharing attention between vision and audition and doing the best you can. But there is some evidence that that kind of multitasking can lead to perceptual impairments. There's a research group at the University of Utah that has studied people in a driving simulator while they are talking on a cell phone, and they found that their reaction time to respond to, say, the appearance of a brake light in the vehicle in front of them is significantly lengthened if they're engaged in a cell phone conversation as compared to just passively listening to the radio. So our study provides a neurophysiological underpinning for that behavioral finding, suggesting that when you turn the volume down on the visual system so that you can pay attention to an auditory input, not only does that change your brain state, but it also reduces your sensitivity to visual events in the scene in front of you.